Okay, so in 9.1, we're going to be learning about vectors in 2 dimensions. So today is going to be a lot of vocab and background so that we can start applying these to real-world situations. Hey, you've also done some work with vectors in geometry, but I know that was a while ago. And then, like I said, some of you, if you've had physics, you might know some of these operations. So we're going to learn how to find something called the magnitude today, and then perform basic operations. Okay, so a vector is something that's defined by its magnitude, and sometimes this is going to be called scalar. Okay, so that means you're going to have one value it's assigned to. So things that are scalar would be length. Okay, so if you're trying to find the length of something, you know, it might be 5 meters. Okay, it's defined by that value. Okay, or if you're working with mass, your only unit would be kilograms. So maybe it's 1 kilogram. Okay, it can be something like area. It can be temperature. Okay, energy. That's measured in joules. Okay, so anything that just has this one value. Okay, but when we're describing displacement, 2 numbers are going to be required. The magnitude and do you guys know what else vectors describe? The direction. Okay, so you're going to have magnitude and the direction of the displacement. Okay, so a common value that we use this in is the velocity. So if you're trying to find the velocity of a moving object, oh, this should say, we must specify both the speed and the direction. Okay, and there are several quantities that involve both of these. And some examples with that would be, like we said, displacement, velocity, acceleration, and force. Okay, would you just raise your hand if you have taken a physics class here before? So, what that will be fresh. Does it have vectors in it? Okay. So when you have these 2 quantities, we use vectors to represent them. Okay, and a vector in the plane is just a line segment that has an assigned direction. Okay, so like I said earlier, okay, this is something that you were introduced to in geometry. Okay, and in this textbook, they will label the vectors in bold. Okay, and we will label them like this. So if we were saying vector u, okay, that would be the same thing as vector AB. Okay, and then you have these 2 points. So one of them is called the initial point. that's where you start. Okay, and then the point the arrow is going to is called the terminal point. That's where it ends. Thank you. Okay, so we mentioned magnitude, okay, and the length of the line segment, that is called the magnitude. Okay, and the way that we show that is the absolute value symbol. Thank you. Okay, so the length of the line segment is called the magnitude of the vector. And then this is your symbol. You have the vector inside the absolute value symbol. Okay, and two vectors are considered equal if they have equal magnitude and the same direction. Okay, because you could have equal magnitude but go in different directions. Okay, so they're only equal if they have both the same magnitude and direction. Okay, when you are representing your vector, you're going to use some special symbols. So we can represent the vector v as an ordered pair of real numbers. Okay, so this is how we write the notation for the vector. You can let me know if you've seen this before. So I call them arrow brackets. It really is a less than sign and a greater than sign. I call them, did I say arrow? Arrow. Because it looks like an arrow here and an arrow here. Have you guys seen this notation before? Okay. So this is how you're going to be writing your vectors. Don't worry, we're going to practice a lot, so that will become second nature. Okay, in this representation, A is called the horizontal component. And B is the vertical component. As we get into some of the directions, we're also going to assign directions to the horizontal and the vertical. Okay, we'll talk about that more tomorrow. So a vector represents a magnitude and a direction, not a particular arrow in the plane. So this vector has many different representations. Okay, and it depends on your initial point. Okay, so you can observe this in these pictures below. Okay, so every single one of these have the same A and B value. Okay, all of these vectors would be A and B. Right, they all have the same magnitude, but their positions in the plane are different. Okay, so this vector, many different representations, but if you were to plot a point, could you put AB anywhere in the plane? No, if I asked you to graph 3, 4, you should all have the same exact graph. Okay, if I asked you to graph the vector 3, 4, we could have 20 different representations. Okay, it all depends on the initial point. Okay, so the difference is the vector has many different representations. okay, while the point is only going to have 1. Okay, so we are going to learn about different forms of vectors. One of them is called component form. Okay, so if you are writing a vector in component form, you have the initial point and the terminal point. Okay, and you can find those by just subtracting. So your initial point, P, is denoted as x1, y1, the terminal point, Q, and that's what we'll be using for these P and Q. Okay, all you have to do is x2 minus x1, and then y2 minus y1. Okay, so you always take the terminal point, we're going to call TP, and subtract the initial point. Okay, that's what's happening. Okay, so in example 1, you have to express the vector in component form. So sometimes it's going to be given to you on a plane, and there's a couple different ways that you can do this. So you can find the 2 points. So point P is at 2, 1. Okay, Q is at -3, 4. And then your P is always the x1, y1. Here you have your x2, y2. Okay, so we can use this formula. Okay, so we just do -3 minus 2, comma, 4 minus 1. Okay, so -5, 3 is going to be your component form. Okay, if you remember from geometry, you can also calculate. Remember that this is the horizontal component. So if it's going 5 to the left, it's a negative value. If it's going up 3, that's a positive value. You could also just count the points. Okay, so you could use either method. Okay? All right, do you guys have any questions about that? All right, then you go ahead and do part B, and we'll check our answer together. Okay, Lily, what'd you get for your horizontal component, and tell me how you found it? So the x's is going to be the horizontal.
X?
Mm-hmm.
I did x2 minus x1, so 5 minus 2, I got it.
Perfect. Okay, and then Sarah, how'd you find the vertical component?
I did 4 minus -1, so I got 5.
Great. Okay, so that minus the negative is going to turn into a positive. Okay, now we are going to sketch the vectors, and they give you the initial point. Okay, so you're going to sketch the given vector. Okay, they tell you the initial point, and then you have to find the terminal point. Okay, and then so you have the 4, 3. We are going to have to, because we have a limited thing here, we are going to have to scale this by 2s. When you're doing this on your own graph paper, you can go by 1s and start wherever you would like, and then you'd be able to extend it. Okay, so if I scale this by 2s, I have 2, 4, 6, 8, and then I'm also actually don't think I need to scale this one by 2s. I can scale this one by 1s. Okay, so if your initial point is 4, 3, okay, we're going to go over 4. We're going to go up 3. Okay, so they give you the initial point. So 4, 3, that's your x1 and then your y1. Okay, and there are several different ways that you can do this. You know that you have a positive 4. Okay, so you can go to the right 4 and then down 3 to find where that other point is, or you can find it algebraically. So according to our formula, we know that if we have x2 minus x1, that's going to equal the horizontal component 4. Okay, and if you're given the initial point, you can just plug that in and solve. Okay, so your x2 would be 8. Okay, which again, if you plot this, which I'll show you in a second, you'll get the same thing. And then for the second one, you can solve with algebra. So you know that y2 minus y1 is equal to negative 3. Okay, so your y1 is right here. That was given to you as the initial point. So if you add 3 over, y2 is going to be 0. Okay, which means your terminal point is going to be 8, 0. Now this is a point. Okay, so if it's a point, you got to use the parentheses. Okay, and then like I said earlier, you can also just take this to mean this is going right, this is going down. So if you went right, 2, 4, if you went down, 1, 2, 3, you would be at this point. Okay, and then you could just label it there. So whatever method you want to do, you can do. And then when you are drawing your vector, when you're sketching the vector, you're going to do a straight line, and then the arrow is pointed at the point. Don't make it past the point. Okay, you want it pointing right at the 8, 0 mark. Okay, so I'm going to have you do part B. And you can scale this by 1s. Okay, so for B, you can scale each of those by 1. And like I said, when you're doing this on your own, you don't have limited space. So. Okay, so you can either find it algebraically, or if you like doing the counting. Okay, and then you do have to label what your terminal point is, okay? Okay, and remember the terminal point is the same as last time. So you have your 4, 3. So if you want to graph that, you can. It's a different color this time. Okay, so if you have -8, negative means you're moving what direction? Left. Okay, and this would be down 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, down 1. Okay, and then we'll break out the straight edges tomorrow. Maybe you should break them out today. Okay, and then just make sure that you have your arrow here. If you set it up with algebra, it's just x2 minus 4 equals -8. So if you add 4 over, x2 is -4. Okay, and then y2 minus 3 equals -1. If you add 3, you get 2. Okay, so your terminal point is a -4, 2. Okay, and then they call it U, so when you're labeling that, you usually just put it right there. And same thing with this, you just label it as U in your diagram. Okay, something we're going to use when we go to the applications is the addition of vectors. Okay, so if the displacement of a vector u is followed by the displacement of a vector v, which we're just going to call BC, then the resulting displacement is going to be the vector AC. Okay, so the single displacement represented by the vector AC has the same effect as the other two displacements together. Okay, and we call the vector AC the sum of the vectors. Okay, the vector sum. AB and BC. Okay, so what we would write is that AC is equal to AB plus BC. Okay, so in this first figure here, we have something similar to that addition. So let's use some color theory here as well. So if you have vector u and vector v, okay, those two displacements, blue and yellow, make green. Go green. There we go. Okay, so that is the exact same thing that we were talking about here. And I know sometimes it's hard to make sense of all these letters together. So you have a point A, you have a point B. This is your vector. Okay, what this is saying is if you do this displacement, so it's just this motion, right, from A to B, and then you do another motion, okay, from B to C, which we would call this BC, that's the same thing as just going from A to C, which if you think back at our treasure hunt with our polar coordinates, that's very similar. Remember how we talked about, oh, if it's rectangular, you go here and here, but it's a lot quicker to just go in the straight line. Okay, that is similar to your vector addition. Okay, we also have something called the zero vector. So if it's a bold 0, that's going to represent no displacements, i.e. it's not going anywhere. Okay, and then when you are finding the sum of any two vectors, okay, we sketch the vectors equal to u and v with the initial point of one at the starting point of the other, which is exactly what we just did. So you had the terminal point B, which is now becoming the initial point. If you've taken physics before, do you guys remember what that term is called? Head to tail? The head to tail method? Yes, no, maybe so. Okay. Yeah, that is familiar. Okay, so we're going to sketch those vectors equal to u and v with the initial point of one and the terminal point of the other. Okay, now when you are doing the vector addition, okay, if you draw u and v starting at the same point, this would not be the head to tail method. So if you draw u and v starting at the same point, then u plus v is the vector that is the diagonal of the parallelogram. This is what we're going to be using in our application process tomorrow. Okay, so you have the same initial point. Okay, what this is telling you is if you start these at the same initial point, when you're trying to find the sum of the two vectors, it is the diagonal of the parallelogram formed by these. So you can construct the parallel sides. Okay, so we are going to be practicing that tomorrow. Okay, thanks for hanging in there. I know it's a lot of terminology today. Okay, and tomorrow we'll put a lot of this in motion. Okay, so with the multiplication of vectors, if A is a real number and V is a vector, you can define this vector as follows. The vector has a magnitude of A times V. This is the magnitude notation, and it has the same direction as V if A is positive. So that just means you have a positive value. Okay, and the opposite direction if A is less than 0. Okay, so the same direction if A is positive, and it is going to be, and the opposite direction if A is negative. Okay, so negative is the opposite direction, positive, same direction. Which again, we can relate that back to the polar coordinates when we were working with those R values, right? And if it was negative, we went in the opposite direction, the opposite quadrant. Okay, and then if your value of A is 0, then you're going to get the 0 vector. Okay, so the way you would write this is A times the vector equals the 0 vector. Okay, and then that process is just called the multiplication of vector by a scalar. When you multiply a vector by a scalar, it has the effect of either stretching or shrinking. Okay, and then figure 3 is going to show graphs of vector AV for different values. Okay, and we're going to write the vector -1 as negative V. Okay, and we're going to look at those values as well. So if this is V, right, half of V is going to be half the size. Okay, 2V is twice the size. If you have the negative, it goes in the opposite direction, but it's the same length. Okay, this would be the opposite direction and 1/3 of the size, the opposite direction and twice the size. Okay, and then like we just saw, when you have that negative, it's going to be the same length, but the opposite direction. Okay, we're not going to be using the subtraction as much, but the difference of your two vectors, a minus v or u minus v, is the same thing as taking the value of u and adding the opposite. Okay, so in your figure here, this is going to be the u plus v. Okay, and then the opposite is going to be the subtraction. Okay, so if you start with those two vectors, just like we've done before, you have your u and your v. Okay, this is the addition one that we just looked at. This is going to be the subtraction. It's going to form the other diagonal. Okay, so there's a lot of different properties here that are listed in your book, but I feel like a lot of them are just going to come naturally to you. So I put them on here so you could look at them. The main one we're going to focus on is the magnitude of a vector. Okay, and again, look at how this relates to our last section. The magnitude of a vector is the square root of a squared plus b squared. Okay, that's when you have the vector AB. Okay, and then when they talk about the operations, like I said, this is intuitive, right? If you add them together, you add the same components together. Okay, if you subtract them. If you multiply by a constant, that's what's going to happen. You just multiply each component there. Okay, and then you still have these commutative properties and associative properties that you have when working with numbers. Now, we're also just going to go over these two boxes, the horizontal and the vertical components of a vector. Okay, so let v be a vector with a magnitude v and a direction of theta, which we will get into that as well. Then the vector v, okay, is going to be calculated by doing the magnitude times the cosine and the magnitude times the sine. Okay, so the horizontal and vertical components. Horizontal is going to be cosine, vertical is going to be sine. And then the other way that we're going to write this is vectors in terms of I and j. So the vector can be represented in terms of I and j, like this. So you'd write the horizontal component in front of I and the vertical component in front of j. Okay, so we're going to summarize that below so you have something quick to look back at. So your horizontal component is always going to be the magnitude times the cosine. Okay, and we do need to know that this means the magnitude. Okay, so this is going to be your magnitude. And then the vertical component we call B, and that is the magnitude times the sine. Okay, and then AB. Your book calls this vector form or component form. So there's going to be different forms they're asking you to write them in. Okay, and sometimes your book will call this component form, and I don't like it. So anytime I want you to write it in the terms of I and J, I will say that. Okay, so this is equal to AI plus B times J, and that would be a vector in terms of I and J. Okay, so you will be required to write in those different forms there. Okay, and the last page is just going to be calculations. Okay, so you're going to be finding these values. Okay, we're going to do one together, and then I'm going to let you have some time to do that so you have time to practice. Okay, so in example 3, you're finding 2u, negative 3v, u plus v, and 3u minus 2v for the given vectors. Okay, so you have to find 1, 2, 3, and 4 calculations. Okay, so if you're doing 2 times u, okay, all we have to do is multiply both of these components by 2. Okay, so 4, 5, 4 times 2, 8, 5 times 2, 10. Okay, it really is that simple. When you're doing negative 3 times v, you are just multiplying by negative 3. So a negative times a negative becomes a positive. 4 times negative 3, negative 12. Okay, and then when you have u plus v, that's when you're going to add the components together. Okay, so your components are the A1, B1, A2, B2. So you're just going to add the horizontal components. 4 plus negative 3, you'll get 1. 5 plus 4, you'll get 9. And then the last one, 3u minus 2v. Okay, so for one like this where you have to multiply both, I actually like to do the 3u first. So 3 times 4 is 12, 5 times 3, 15, and then add it. I like to add it to the negative 2v, okay? So it's the same thing as plus negative 2 times v. Okay, so a negative times a negative, positive, negative 2 times negative 4, and then I can just add. Okay, if you want to do subtract and distribute the 2, that is fine as well. Okay, so then we get 18. 15 minus 8 will be 7. Okay, so I'm going to have you do B. Just put your device up there. Just in the box or the thing. Okay, so for 2u, Landon, what'd you get for that one?
2u.
Yep,
-2, comma,
great. Okay, -2, -6. Maya, what'd you get for -3v? That flip it around. So it should be 6. Yes, yep. And then Berkeley, what'd you get for u plus v? Oh, Berkeley's not here. Sorry, Addie, what'd you get? U plus v.
-3. Or
Neg-
-1.
Yes, -3, -1. Good. And then Esther, what'd you get for the last one? Great. Okay, and then will you guys just double check and make sure you have the right notation, that you have those arrow brackets? Okay, and then for example 4, you are finding the magnitude. Okay, so the magnitude is the square root of a squared plus b squared. Okay, so for vector u, they give you -2i plus 2j. For v, they give you i plus j. If you want to write these in component form, you can. So in component form, it would be -2, 2. And then the coefficient of I is 1. The coefficient of j is 1. Okay, so if you want to write those and then use that for the magnitude, you can. Okay, so for u, we have -2 squared plus 2 squared. So 4 plus 4, √8. We are going to write these in simplest form, so 2√2. Okay, and then your magnitude for v is the second thing we're going to find. So the square root, 1 squared plus 1 squared, 1 plus 1, √2. Okay, and you're going to leave it as that exact value. Okay, now, when you are doing one like this, the 2u, okay, if you want to find the vector first, you can just multiply that by 2. So you'd have -4 and then 4. And then when you find the magnitude, okay, -4 squared is 16. 16 plus 16, square root of 32. What's the largest perfect square in 32? 16. So it's going to simplify 2 or √2. Okay, now look at u and then look at the magnitude for 2u. What happened from here to here? Just multiply by 2. So if you want, you can take a shortcut, right? If you have 2u, you can just multiply that by 2. Okay, and that would be fine. All right, so we can use that with the 1/2 u as well. Okay, so, or v, sorry. So if you do the 1/2 v, okay, it really is just taking 1/2 and multiplying by your magnitude of v. So 1/2 times √2, how would we write that? √2 over 2, yeah. Okay, now for the u plus v, we are going to need to find that vector. Okay, so when you add -2 and 1, you get -1. 2 plus 1 is going to be 3. Then we can find the magnitude. Okay, so see if you added the two magnitudes together, that would not be root 10. Okay, 2 root 2 plus root 2 is actually 3 root 2 and not root 10. So if you're adding or subtracting, you do have to find that first, okay? All right, and then the last one, or sorry, this is the second to last one. You have your u minus v. Okay, so you need to subtract first. Negative 2 minus 1 is negative 3. 2 minus 1. Okay, so when you do the magnitude, it's just the square root. Negative 3 squared is 9. 1. Okay, and you just happen to get root 10 again. That will not always happen. Okay, now this is the absolute value of u minus that magnitude of v. So the absolute value means the magnitude. So in that case, you can take the magnitude that you've already found, 2 root 2, okay, and you can minus root 2. If they are like terms, you can combine them. If they're not, you just leave it as subtraction. So with square roots, they're like terms if it's the same radicand and the same root. So you do have like terms here. Again, that's not always going to happen. Okay, 2 root 2 minus root 2 is what? Yep, just root 2. Okay, and then in example 5, it says find the horizontal and vertical components, of the vector with the given length and direction, and write the vector in terms of the vectors I and j. Okay, so to find each component, you're going to use the magnitude times the cosine and the magnitude times the sine. Okay, in this case, they give us the magnitude and they give us the angle in degrees. Okay, so we are going to be using degree mode here. Okay, so I want you guys to plug in those values from the unit circle and simplify. And then you will need your calculator for part B. Okay, so what is the cosine of root 30? Or sorry, what's the cosine of 30? What do you guys plug in? Root 3 over 2. Yeah? Okay, and for the sine of 30? 1/2. Okay, so when you are simplifying, your b value is 2. Okay, 4 divided by 2, this is going to be 2 root 3. Okay, and then if you're writing this in terms of I and j, it'll be 2 root 3i. And you can just put it right outside there, plus 2j. Okay, now, when you are doing this, you need to make sure that you are in degree mode. Okay, so for A, you have 2 times the cosine of 15 degrees. That's not an exact value on the unit circle. Okay, and you're just going to round to the nearest hundredth. Oh, I always do the fancy I so that we don't confuse it for something else. I always do an italicized one. Okay, so we're going to go to mode, okay, and we're going to make sure that we are in degree. Okay, and then from there you can do 2 cosine of 15, 2 sine of 15. Okay, and like I said, we're going to round those to the nearest hundredth. So you get 1.93 and then 0.52. Yeah, sometimes when people write their I's, they it looks like a 1, so I'll always make it the italicized 1. All right, and then the last thing we're doing, you actually did this in geometry. So you're finding the magnitude and the direction in degrees of the vector. When you're finding the direction in degrees, you don't have to label like north, west, east, south. We are going to do that tomorrow. Okay, but to find the magnitude, we've done that today. So we're just going to do -4 squared plus 3 squared. Okay, 16 plus 9 is 25. Square root of 25 is going to be 5. Okay, so when it says find the magnitude, okay, you are using that square root of a squared plus b squared. When you're finding the direction of the vector, you are going to use a good old friend. Tangent of theta equals b over a. Okay, so then the tangent of theta would equal 3 over -4. Okay, and if this is not somewhere on the unit circle, then we're going to use the inverse. Now, the same things apply from the last chapter. Okay, so if you have the -4, 3, okay, you use those signs, the negative, positive. This should be in quadrant 2. Okay, so when you do the inverse, let's see what we get. 3 divided by -4. Okay, you get -36.87. Okay, that is in quadrant 4. So, in order to get it in the opposite quadrant, what do we need to add? Yep, so in degrees, that would be pi is equal to 180. Okay, so in degrees, theta is 143.13 degrees. Okay, when we start to do bearings, that will change a little bit, but if it says in degree, you're just going to make sure that the degree matches your direction there. Okay, and then if something's given to you in I and J, if you are more comfortable with it in this form, you can always rewrite it. Keep in mind, when you square a square root, that root goes away, and when you square a negative, it's still going to be a positive value. So root 3 squared becomes 3. 3 plus 1 is 4. Square root of 4 is 2. Okay, this is the magnitude. Okay, magnitude is equivalent to the length. Okay, now for this one, when you do your b over a, we can rationalize. And if we rationalize this, this is a familiar value. Okay, there are 2 places where the tangent is -√3/3. Because this is a positive and a negative, we have to find this in quadrant 4. Okay, so Do you guys know what that's going to be in degrees? So we're going to do it in degrees. So it'll 11 pi over 6 will be 330, or you could also just call it negative 30. Yeah, so this one will be a little bit different because we are working with degrees in chapter 9. That's why we did a little bit of that in chapter 8 as well.